Maple TA Lesson 13, homework question number 9. Suppose you want to save $7,500 to go on a dream vacation in 3 years. Step number 1, understanding the problem. You can save for your vacation by either depositing one single lump sum of money into a savings account and letting it accumulate interest, or by making regular monthly payments. Step 2, identifying variables and assumptions. Identify which two of the following variables would not be useful in understanding the financial situation. The first one says the interest rate on the savings account, so that sounds very important. The next one, the amount of money you would need to deposit in the savings account as a single deposit, that also sounds very important. The next one, the type of clothes you will bring on your trip, also important, but not in the savings part, so I'm going to skip that one. The next, the people you hope to take or meet on your trip, also important, but not as a part of our savings part. And the last one, the amount of money you would need to deposit in the savings account each month. Very good. So we're looking for the ones that are not. So I was looking at the ones that were. So these are the two that are not as useful in finding our financial situation. The next one, identify which two of the following assumptions would not be useful in understanding the financial situation. Okay, dreams are for fools. That's not helpful. The next one, when you wish upon a star, your dreams come true. Also not useful in understanding the financial situation. Then $7,500 will be enough money for your dream vacation in 3 years. Fantastic assumption. And then the interest rate for either account is 1.5% APR. I'm going to assume that that is true. It wasn't told to us, but we're going to go with that one. And so that these two are not good assumptions. So we're going to hope that that's the interest rate that we are getting in our account. Okay, number 3. Apply quantitative tools. How much money as a one-time deposit, or the present value, would you need to deposit into an account that earns 1.5% compounded monthly to earn a future value, or FV, of $7,500 in 3 years? I should put that over here, and I didn't. So we need APR is 1.5%. I apologize, that wasn't put in my little Excel spreadsheet over here. So let's see. This amount can be found by using algebra to rearrange the function FV, the future value function, equals PV times the quantity 1 plus R over N raised to the NY, so that the future value becomes the input variable and the present value becomes the output variable. So all we've done is we have solved for PV here by dividing both sides by this, which puts it on in the denominator, and when something goes in the denominator, it can be brought back up to the numerator with a negative exponent, which is where this came from. If you'd like to see a more detailed algebraic workout of that, I could do that for you, but at this moment I'm not going to go through it. So we could do all of this and type it all in, or we can use Excel. So I'm going to do both ways. Use this function to find the amount needed as a one-time deposit to earn $7,500 in 3 years. So the first thing I'm going to do is do the Excel present value function equals PV, and then I'll go through and actually type it in as you can see in the equation here. So the first thing I want to do is the rate, and I have it here, so I'm just going to cell reference. And don't forget, we always divide by 12, or compounds in this case, since it's 12 months. And number of periods, again, 12 months in a year, times 3 years, because we're saving up for 3 years. We are not making a payment here, so we're going to put 0, and the future value is 7,500 here for our lump sum, right here for our lump sum amount. So we're going to type in $7,170.80, or 18 cents. Whoops, 18. There we go. Now the next one says what monthly payment. Oh, I said I would do this, working it out. So if I wanted to type all of this into Excel like the equation I can do that by, I need my future value, which I know is 7,500, and I can type that in with the digit 7,500, or because I have these here, I can still cell reference. And then I'm going to multiply that by the quantity 1 plus r over n. So we're going to do 1 plus our rate divided by 12, just like we did in our Excel version, and then raise this to, don't forget to do another set of parentheses for both n and y to be in the exponent, n being 12 and y being the time in years, or y, and double checking, making sure I get my multiplications, divisions, power, parentheses, everything looks good. So I'm going to press enter, and we have something a little different here. So let's go back and check what happened. I see I forgot to put my negative in here, so we're going to type in a negative. Press enter. There we go. I apologize. That was my mistake in this part. It's good to go through both of those. It's a good way to double check your work. Okay, what monthly payment, PMT, would you need to deposit into an account that earns 1.5% compounded monthly to earn a future value, or FV, of $7,500 in 3 years? So again, we have our two ways. We can do the equation or Excel, and so I'll just do both so you can see both of those worked out. This amount can be found by using algebra to rearrange the function future value equals payment times 1 plus the rate, APR over n, raised to the ny, n being the number of compounds in a year, minus 1, all divided by r over n. So the FV becomes an input variable and payment becomes the output variable. And so we get this formula right here. Again, if you'd like to see that worked out, you can, I can do a video for you, or you can just say we don't divide by fractions, we multiply by the reciprocal. And so to solve for payment here, we multiplied both sides by this big, huge reciprocal, which puts the r over n on top and all of the rest on the bottom. Okay, so again, you know what? I'm going to do it backwards this time. I'm going to do the long formula first, and then we'll use the Excel version to, we hope, have that one work out better than the last one. Okay, so we want our future value first, future value. And again, I'm just going to cell reference here and multiply that by, we have r over n. So I'm going to reference r, divide by 12, and then divide this whole thing by this large complex or compound fraction. So we have 1 plus r over n, and I'm going to do two sets of parentheses right there. One to specify the entire denominator, and then the next set right here to specify the 1 plus r over n. So I'm going to do 1 plus r, and I'm going to cell reference again. And if you don't want to do this, you could be typing in the 1.5. However, I find it much easier to, even in these problems like this, give myself a little chart over here and just cell reference so I don't make any typos. R over n, and then raise this. Now again, remember, n and y need to both be in that exponent. So we're going to put parentheses and multiply n and reference y and close parenthesis, and then we need to subtract 1 and close parenthesis. And you'll see that Excel is nice enough to color coordinate these parentheses since we have so many embedded in here. This black one shows the beginning of this parenthesis, and this black one shows that I've ended that parenthesis. So those are in there. I have this red parenthesis and it ends here, and this other set of red right here for the exponent. Again, I'm going to double check here, and I hope this one works as opposed to the last one, and it looks like everything's in there right. I didn't miss any negatives this time, and we're going to double check using Excel. So I'm going to do equals PMT, and this one's much faster, so we'll just cell reference our rate. Don't forget you have to divide it by 12, comma, number of periods is 12 months in a year times 3 years. Then present value, we don't have a present value, so we're going to do 0, but we do have a future value. We want it to get up to 7,500, and pressing enter. Hey, those two match, so we did it right. So we can come over here Use this function to find the amount to deposit in each month. So we know we need $203, and it doesn't tell me what I should round it out to, so I'm just going to do the nearest dollar. And so it rounds up to, we'll cross our fingers and hope that 204 works. Oh, no, let's do 203.81. Just to be, we'll hope rounding to the nearest cent will work. The next one, how much money would you need to deposit if you made this monthly deposit for 3 years? Oh, I think this is asking how much total money after we deposit this 2003 or the $203. So we're going to take our 203 and we're going to multiply that by 12 months, times it by 3 years, and that tells me how much money I put into the account versus how much interest I ended up earning. So how much total money? And I'm going to just type this in. We could copy and paste from Excel to spare us any, hopefully, typos, but I'm going to double check that, and it looks good. Okay, the next one. Which saving option is the least expensive? We could save, or we could do the lump sum, which is $7,170, or the payment is $7,337. So the lump sum saves us a couple hundred. So I'm going to say the lump sum is the least expensive, or the one-time payment. And then, which savings option would you choose? So I could make monthly deposits. It is not the least expensive option. The next one, monthly deposits, because it is too difficult to come up with the amount needed for a one-time deposit. If you have the $7,170, then that would be least expensive and putting it in for a one-time deposit. But that sounds kind of silly to be investing for less than $300. But we could if you have $7,000. I'm guessing that that extra 300 isn't going to be that much beyond that. So I'm going to say, and this last one, a one-time deposit, because it is the least expensive option. It is, however, that's a lot of money to put down. So I'm going to go ahead and put option number 2. All right, and our last one, identify which 4 of the following events might affect how you follow through with your plan. So we're looking at the 4 events and follow through. Okay, the first one, you inherit $7,000 just before you begin saving. If I had that $7,000, I could just put it in a lump sum, and so that would change my that would affect my follow through. The next one, after 3 years of savings, you decide to give your money to charity. This does not affect my follow through of saving and either doing a monthly or a lump sum, so that doesn't affect the follow through. The next one, after your dream vacation, you never want to leave home again. Again, this doesn't affect your follow through of your savings. And the next one, while you are saving for your vacation, your car stops running and you need an expensive repair. That definitely would affect my follow through. The next one, after your dream vacation, you decide to travel more frequently. Again, that doesn't affect anything in this one, in the savings in this situation. The next one, just before beginning to save, you lose your job. That definitely affects how I would be saving for a dream vacation or putting it off, definitely affecting my follow through. And the last one, after saving for 1 year, an outbreak of a very contagious 2-year plague hits your dream vacation site. So that one does change my follow through on that one as well. Okay, so let's just get our validation of the green check marks and move to the next question. Oh, this is the end. Good luck on the next assignment.